Rounding out Module 14, we have Lesson 14.3, and now we're focusing on ordering these real numbers that we've been learning about. So between any two real numbers, there is another real number. And so to compare and order those real numbers, we can approximate irrational numbers as decimals, which is what we were doing in lesson 14.2. So now we need to know how far do we need to go. We need to keep going to a smaller place value until the digits are different and we're able to compare them. And when do we need to use a calculator? We need a calculator to estimate an irrational number when you are comparing it to a number that is very close to the estimate. So now let's look at that below. Here we have the square root of 8 minus 2 and 4 minus the square root of 8. And so what we're going to do is compare that with a less than, greater than, or equal to. And as we know, the square root of 8, well, 8 is not a perfect square, so we're going to have to estimate. But I know in my list of perfect squares that the square root of 8 falls between the perfect square of 4, so the square root of 4, and the perfect square of 9, the square root of 9. So the square root of 8 is much closer to the square root of 9 than it is to 4, and the square root of 4 is 2, and the square root of 9 is 3. So therefore, the square root of 8 is very close to 3. So I'm going to approximate that as about 2.8. So about 2.8, but then we need to subtract 2. So that is approximately 0.8. And now we're going to do the right side, 4 minus the square root of 8. And as we already did here on the left side, we approximated the square root of 8 to be about 2.8. So 4 minus 2.8 is 1.2. So now we have 0.8 and 1.2. And clearly we can see that 0.8 is less than 1.2. Now for B, we have the square root of 20 plus 1. And then on the right side, we have 3 plus the square root of 2. So for the square root of 20, that falls between the perfect square of 16, so the square root of 16, and the perfect square of 25. Well, the square root of 16 is 4, and the square root of 25 is 5. And I would say that 20 is closer to 16 than it is to 25, as it is 4 away, but it's real close to being right there in the middle. So I'm going to say this to be approximately 4.4, but then when we add 1 to it, it becomes 5.4. And now I'm going to do the same thing on the right side. 3 plus the square root of 2. Well, the first perfect square I have is 1. Square root of 1 is 1. And the next perfect square in my list is 4. The square root of 1 is 1, and the square root of 4 is 2. 2 is much closer to 1 than it is to 4. So as an approximate, about 1.2. But I'm adding 3 to that, so that is 4.2. So now 5.4 and 4.2. Well, 5.4 is greater than 4.2. So now what I'd like you to do is pause this video and try the next 2 your turn questions on your own, and then check your work with mine. All right, so number 1 with this your turn, we've got the square root of 2, which we've already approximated in example 1 to be about 1.2. So 1.2 plus 4 . 5.2, and then we've got 2 plus the square root of 4. Well, square root of 4, that's a perfect square, so really that just becomes 2 plus 2, which is 4, and clearly 5.2 is greater than 4, so my greater than symbol is what goes here. And now for number 2, we've got the square root of 15 plus 6. So 15 is not a perfect square, so I'm going to estimate. And in my list of perfect squares, 15 falls between 9 and 16. The square root of 9 is 3, and the square root of 16 is 4. Well, 15 is much closer to 16 than it is to 9, so I know that my decimal approximate is real close to 4. So I'm going to say about 3.9 plus the 6 is about 9.9. And then I've got 15 minus the square root of 6. So now I'm looking at 6, and where does that fall in my list of perfect squares? And that falls between the square root of 4, 4 as my perfect square, and 9 as my next. The square root of 4 is 2, and the square root of 9 is 3. And 6 is much closer to 4 than it is to 9. So my approximate here is 2.4. Now keep in mind, if you maybe gave me 2.3, that would be sufficient as well. And then 15 minus 2.4 is 12.6. So 9.9 is less than 12.6. And now lastly, we have this example here where we are going to order these numbers here, these real numbers here. The first one we have is 3 times pi, the square root of 10, and 3.25. Well, 3.25, there's nothing more that I need to do other than to analyze where it falls at in my list from least to greatest. So I'm going to start with the first one, 3 times pi. I'm going to use 3.14 as pi, and I'm going to take 3 times that. And 3 times 3.14 is 9.42. And then I'm going to approximate the square root of 10. And so the square root of 10 falls between the perfect square of 9 and the perfect square of 16. Square root of 9 is 3, and the square root of 16 is 4, and 10 is much closer to 9 than 16, So my approximate here is going to be about 3.1 because it's just one digit away. So I have 9.42, which is much greater than 3.25 or 3.1. So the smallest value that I have here is actually the square root of 10, which I have as 3.1 about. So in my list from least to greatest, I am going to list them out as the values that they are in the original list. So I'm going to write it out as the square root of 10. And then the next in my list is 3.25, followed by 3 times pi. So there I have it, my list from least to greatest.